Hello, I am Madam Gracious Kanzini from Educare, Tanzania. Warmly welcome in our media so you can proceed in our A-level tutorial. And here, my students, we're going to learn on our chemistry subject, and our main topic is general chemistry. As I've said that in our general chemistry we have two main subtopics, the atomic and chemical bonding. But here we are dealing with the atomic. And in our atomic we have many subtopics, only 4 main subtopics. We have the Dalton atomic theory, Bohr's atomic theory, the atomic mass, and the last one is the quantum theory. So here today, my students, we are going to look on the Bohr's model of an atom. The Bohr model of an atom. Kumbuka, his models of an atom are the earlier scientists tried to propose or to suggest the idea and the experiment which will provide the evidence toward the identification of atomic structure. Sasa tuliona kuhusiana na J.J. Thomson, tuliona kuhusiana na Rutherford ambapo alikuja na alpha scattering particle, akatumia experiment ya Goldleaf, lakini pia finally akaja kufanya relation ya the way a planet revolve around the sun and the way electron revolve around those orbits. Na in the J.J. Thomson alikuja na idea ya kwamba plum pudding, alichukulia mfano wa mbegu za matunda la watermelon, lakini pia akachukulia bread cake ambayo imekuwa spreaded with those sweet dry grapes. Lakini sasa tukaenda kuangalia model ya Bohr's model. Yeye alizungumzia nini kuhusiana na the atom, the structure of the atom, depending on the Dalton modern atomic theory, ambapo alisema kwamba atom is made up of those subatomic particles. Challenge ilikuja tu baada ya kwamba huyo Dalton alikuja na modern theory kwamba atom ni made up of subatomic particle. Now let us see about the Rutherford. Okay, the model expanded the Rutherford atomic model that an atom possesses successive orbits of the fixed size and energy where electron travel through. Sasa huyu Bohr yeye alikuja kufanya expansion, aliendeleza. Ina maana uchunguzi wake ulianzia pale alipoishia nani? Alipoishia Rutherford. Alipofeli Rutherford, huyu Bohr ndo akaja yeye na uchambuzi zaidi. Sasa alianzia kwenye issue ya kwamba an atom possesses successful orbits atom possesses successive orbits of fixed size and energy where electron travel through. Kwamba kunakuwa na size lakini pia kunakuwa na orbits, ile miduara ile, lakini pia kunakuwa na energy. Kwa hiyo alipokuja na hii concept ya fixed size and energy ambapo electrons zina travel, tunaona kwamba electron anaweza akawa excited akitoka kwenye level 1, level 2, hizo ndio zile orbit au levels. Umeona? So this Bohr ndio alikuja na hiyo concept. Akaja kuangalia ile fixed size of this atom, lakini pia energy where the electron travel through. Kwamba zile electrons where they travel, they tend to lose energy or sometimes they tend to gain energy. Okay, Rutherford suggested that atom consists of the positively charged nucleus with the negative charged electron revolving in an orbit around it. Kwamba yeye alikuja kusema kwamba the atom ina consist what? The positively charged. Kwamba tuliona pale ndani ya atom pe nucleus pale kuna nini? Kuna ile proton, ambayo always proton we know that is a positive. Akasema kwamba hii nucleus sasa inakuwa surrounded, yani kwenye zile orbit ndipo kunakuwa na nani? Na electrons. Huyo ni Rutherford. Ndio maana alichukulia mfano ule wa the planets revolve around the sun, zile sayari zilivyoje kwenye concept ya solar system ile. So you can see that according to Bohr now, the inner orbits hold fewer electrons that the outer orbit and the number of electron in the outer orbit determine the atom chemical properties. Huyu ni Bohr. Bohr yeye akaja na idea kwamba inner orbit, tunapozungumzia inner orbit tunaongelea ile level za ndani, mean that those orbit near the nucleus of an atom. Sasa akasema kwamba inner orbit hold fewer electron, na you will be utadhibitisha ili pale ambapo unapo draw energy shell utaona kwamba the first energy shell almost anakuwa na 2 electron no matter what, lazima ziwe 2 electron ndio hawa wengine waanze kuwafili, lakini ile ya kwanza kabisa anakuwa na maximum 2 electron. So you can see that yeye akasema kwamba inner orbits anakuwa na fewer electrons than the outer orbit. Ukiachana na wanje anaweza kuwa na electron 6, 7, 8 and so forth. Akasema kwamba and the number of electron in the outer orbit determine the atom chemical properties, kwamba namba ya atom kwenye inner orbit itadetermine ile sifa ya kipekee ya atom, properties of atom. And you can see that upon studying the hydrogen atom, alikuja na studying ya hydrogen atom. Bohr also discovered that when an electron moves from an outer orbit to an inner one, hasa pale ambapo electron anaanza kumove kutoka kwenye inner orbit to the outer one, it emit light. Huyu ni Bohr alikuja na hii idea wakati anasoma the hydrogen atom. Alikuja kuona kwamba electron move from an outer orbit to inner one, it emit light. Na maana akitoka kwenye outer to in, yani outer to in, anafanya emission or anafanya emitting of the light. Also, when an electron absorb light in the form of photons, it move from the inner to the outer orbit. Sasa pale ambapo anafanya absorption of energy, mean that atakuwa ana move from inner to out. Na hii absorption of light, it is made up of, the kind of light here is made up of photons. What is photons? Tutakuja kuona zaidi. Hii ni just introduction ambayo itatusaidia baadaye, kwa sababu hii concept ina maswali ya calculations. Kwa hiyo zile calculation lazima tuelewe huku vitu vidogo vidogo. Okay. So you can see that figure 1.8 A and B show the emission and absorption of photons. Kumbuka photons tunaangalia ile emission of light and absorption of light, lakini kind of light here emitted or absorbed tunasema iko in term of photon. Sasa tunaona kwamba figure 1.8 ambapo kuna A na B inaonyesha hii absorption, lakini pia inaonyesha hii emission of this photons by electron with the corresponding transition. Now let us see our figure 8, figure 1.8. Kuna part A, kuna part B. This is our figure. So as you can see that katika figure A ina undergo emission process. Why emission process? Because there is decreasing in energy. Decreasing in energy mean that it is from the outer, electron tend to move from the outer to in. Pale ambapo electrons zina move from outer to in, mean that there is a decreasing of energy. And the kind of light will be, the reaction of light there, it will be emission. So here the photon emitted kwenye part A. But tunapokuja kwenye part B, tunaona kwamba this is our atom, ambayo it is made up of this nuclear and this kind of energy levels or this kind of shell. But you can see that the photons here is absorbed. Na kama kunakuwa na absorption of photons, simply there is increasing in energy. Energy in increase. Mean that the electron tend to move from inner orbit to outer orbit. Kwa hiyo kuna tofauti mkubwa. Kuna movement of electron from the inner orbit to the outer orbit, ambapo pale tunajua kwamba energy it tend to increase, and when the energy increase mean that there is the absorption taking place. Lakini kama energy ina decrease mean that there is emission taking place, ambapo the electron tend to move from the outer orbit to the inner orbit. I hope that is clear. Hii ndio concept kuu alikuja nayo Bohr. The main concept alikuja nayo Bohr. Okay? Now, let us see the Bohr's atomic theory. Kumbuka tulikuwa tunaangalia Bohr's atomic models. Bohr's atomic models. Sasa let us look on the atomic theory. What are the ideas? What are the postulates? What are the assumptions? So, kuna some of the theories ambazo zilikuwa proposed na huyu Bohr. So, after his exploration and the proposition of the atomic model, baada sasa ile exploration ya model kuangalia sasa ni jinsi gani hizi subatomic particles zimejiarrange kwenye atom, Bohr put forward a model for the hydrogen atom which predicted the existence of line spectrum. Kumbuka kwenye uchunguzi wake au kwenye his experiment alikuwa na deal na concept or studying of the hydrogen atom. Kwa hiyo Bohr put forward a model for hydrogen atom which predicted the existence of line spectrum. Wakati akawa ana study ile hydrogen atom, kulikuwa na predictions of the existence of the line spectrum. What is the line spectrum? Tutaona zaidi. So in this section you will learn about the assumption of the Bohr atomic theory. That's tunaenda kuangalia hizo kind of assumption. Lakini pia we are going to learn on the energy level and the hydrogen spectrum. Energy levels lakini pia associated with the hydrogen spectrum. But finally we are going to look on the nature of electromagnetic radiation in the atomic spectrum. Kwa sababu hatuwezi kuongelea line spectrum kama hatuna kind of light, kama hatuna kind of absorption and emission. Sasa kama kuna hizo kind of emission and absorption, simply there is the issue of electromagnetic radiation. So here in the Bohr is where this issue are discussed deeply. The issue of energy levels and the hydrogen spectrum, nature of electromagnetic radiation, and atomic spectra. Lakini pia bila kusahau the assumption of this Bohr. So simply let us start with the assumption. Let us start with the assumptions of the Bohr atomic theory. Assumption of the Bohr atomic theory. First assumption ambayo nimename kama A, state that the hydrogen atom has only certain allowed energy level called the stationary phase. Stationary phase. Anasema kwamba hii hydrogen atom has only certain allowed energy level. All allowed energy level. And this allowed energy level is known as stationary. Tunaposema kitu stationary kipo tu pale pa. Ina maana hakijafanya absorption yoyote, hakijafanya emission yoyote kwenda kutengeneza kitu kingine. So it is in the origin. Kitu kipo stationary. Yani kipo ni center. That is what we call the allowed energy level of the hydrogen. So each of these states is associated with a fixed circular orbit in which electrons move around the nucleus. Asa kwenye hiyo stationary phase ambapo tunasema kwamba ni this state huwa inakuwa na fixed circular orbit in which within that kwenye hiyo orbit sasa kuna electron ambazo zinatend to around the nucleus. Kumbuka nucleus ipo kwenye center pale. And I mean nucleus is the center of your what? Of your atom. So you can see that another of the ball is the angular momentum of the electron is stationary state. In stationary state is localized. The angular momentum of the electron katika ile stationary state, anasema it is localized, and this is shown in the equation 1.1, that is this one, kwamba mvr is equal to nh2 over 2 pi. Tunasema kwamba the angular momentum of the electron, ile angular momentum ya electron, it is localized, ambapo hii angular momentum of the electron inakuwa defined by this equation. Nasema kwamba katika stationary state au katika ile level ambayo ni ile stationary phase, this kind of electrons zinakuwa localized. They are not free to move kwa sababu hamna absorption yoyote. Kwa hiyo they are not free to move, they are localized. And the simple equation to demonstrate this angular momentum is this one, kwamba mvr is equal to nh over 2 pi. Sasa mvr ina maana gani? Nh ina maana gani? 2 pi, I hope pi is known is constant mathematical value, inajulikana. Lakini n ina maana gani? H ina maana gani? mvr ina maana gani? So you can see that this angular momentum equation ina maana kwamba n ni principal quantum number which can be either 1, 2, 3, 4 and so forth. Kwamba n ina express the quantum number, principal quantum number. Tutaenda kuona hizo principal quantum number wakati tunasoma subtopic ya mwisho kabisa, the quantum theory. Tutaenda kuziona vizuri in detail. But m is mean the mass. Kumbuka tuko tunaongelea angular momentum. M it means the mass. V velocity of electron. And the velocity obviously we are talking about the distance. Kwa sababu tumeona kwamba hizi electron they tend to move, they tend to travel. They tend to move from stationary phase to a certain phase. Sasa lazima tujue the velocity of that electron. R is radius of an orbit, radius of an orbit. And H is the Planck's constant. H ni Planck's constant. Hii ni constant value. But another assumption is the electron does not radiate energy while it is in its stationary phase. Kwamba electrons zinapokuwa kwenye stationary phase, they does not radiate energy. It comes from the word radiation. Radiate. Kwamba hizi electrons zinapokuwa kwenye stationary phase has radiate energy yoyote ile. That is, the atom does not change energy while the electron move within an orbit. Kwa hiyo kumbe zile electrons zinavyo move kwenye orbit, no energy change. No energy change kwa sababu tumeambiwa does not radiate energy. Hamna energy yote inayobadilika. Another assumption is the electron move to another stationary state. Au kumbuka hizo stationary state what ndio zile orbit zile au zile level. Anasema kwamba electron move to another stationary state only by absorbing or emitting a photon of specific energy. Sasa hizo electrons zina move kwenda kwenye level nyingine au kwenye orbit nyingine, endapo zita observe na kuemit a specific photon, where the change in energy is equal to the difference of the energy between the two states. Kwamba change in energy itakuwa ni tofauti iliyopo kati ya zile energy mbili katika ile origin or stationary phase and another phase ambayo imemove kwenda hapo. So mathematically this is represented by equation 1.2 ambapo tunaona kwamba change in E is equal to EU2 minus E1 which is equal to HV. H tulishasema ni Planck's constant, V is the frequency of the radiation, frequency of the radiation. E1 lower energy state and E2 with the higher energy state, ambayo E1 ni pale kwenye stationary phase, lakini E2 ni pale baada ya kufanya emission, baada ya kufanya absorption in the surface. So a photon of specific energy is emitted as the electron move from a higher energy state to a lower one. Kwamba photon inakuwa absorbed pale ambapo electron inakuwa ina move kutoka kwenye lower energy level to higher energy level. Therefore, according to the Bohr, an atomic spectrum is not continuous. Sasa kulingana na hili, Bohr akasema ile atomic spectrum not continuous. Why not continuous? Because the atom energy has only discrete level or state. Lazima kuwe na specific kind of energy depending on the photon absorbed or emitted. Kwa hiyo hii ndio maana tunaona kwamba hii spectrum is not continuous. Now let us see the shortcoming. Hizo zilikuwa ni assumption. Shortcoming of the Bohr. Shortcoming mean that we are looking the limitations, madhaifu, weakness of this scientist. Sasa, although the Bohr's atomic theory was successful in accounting for the presence of the spectral line of the hydrogen atom, it had the following weakness. Yeye aliweza kustadi kuhusiana na hydrogen, akaja na hiyo kind of spectral line, kind of photons, kind of energy, size, fixed of the orbit and so forth. Lakini kuna madhaifu yake ambayo alishindwa kuwa na idea na hizo concepts. So let us see those shortcomings. The first one is it could not explain the spectrum of atom with more than one electron, even that of helium, the next simplest element, kwa sababu yeye alistudy only hydrogen. So what about those atoms with more than one electron? Vipi kuhusiana na helium? Vipi kuhusiana na next simple elements? Sasa zile elements zote ambazo zina electron more than one, how about them? Yeye alikuja tu na studying about hydrogen. But also it could not explain why the energy is quantized. Why the energy is quantized? Kwa nini? Hajatuambia. See, it couldn't to explain the existence of sub-energy level in the main quantum number. Those sub-energy levels he didn't explain. It did not explain why an atom did not collapse as the theory of the electromagnetic radiation predicted. Kwamba depending on the electromagnetic radiation laws there is the collapse. Lakini yeye hajatuambia why an atom did not collapse. Okay, another limitation or another shortcoming of the Bohr was it could not explain the existence of sub-energy level at the main quantum. I've said it. Another one is no justification was given for the quantization of the momentum of the electron. Tuliona tu kwamba the angular momentum of those electron is localized. Tukaona ile formula mvr is equal to nh over 2 pi, lakini hatukuambiwa kwa nini. Akasema n ni quantum principle, quantum number, but he didn't explain at all. But also another is the theory could not account for the shape of the molecule. Hajaelezea wala hajaongelea kuhusiana na shape of the molecule. Another shortcoming of the Bohr is the Bohr idea of the orbit assumed that the electron in an atom is located at the defined distance from the nucleus, and its velocity is defined. However, this idea was later proved wrong by the Heisenberg's uncertainty principle. Kwa hiyo halikuwa hayupo sahihi. Yeye alijaribu kupropose kwa namna hiyo kulingana na experiments zake alizofanya, lakini kuna mtaalamu mwingine alikuja baadaye anaitwa Heisenberg uncertainty principle. Tutaenda kusoma mbeleni hii principle ina maana gani, how we can state this principle, how we can apply it in the different questions. So this is the shortcomings or the weaknesses of the Bohr atomic model. So now, my students, after saying that, this marks the end of our session for today. Thank you so much for your time. Keep watching our media so as we can make this discussion or this tutorial together. Bye bye. Have a good time.